Hello, and welcome back to the Maths Behind the Economics YouTube channel and to the Logarithms for Economics series. In this video, which is video 3, we're going to look at the natural logarithm in details. We will talk about what Euler's number is, then I will introduce the natural log, and as always, there's going to be plenty of examples. Let us get started. On the screen, you can see Euler's number to 15 decimal places. This number is referred to by E. So in economics, if you just see the letter E, it's possibly that it's going to refer to Euler's number, which is this specific number. In most cases, you're probably only going to use it up to 2 or 3 decimal places, and this number is very similar to pi in a sense that this is one of those numbers that have infinitely many decimal places, and it's not one of those numbers that you can express as a fraction of 2 whole numbers. Right, so why E, you might ask? Well, Euler's number is very widely used in economics. It's used when we're calculating continuous compounding, and intimately connected to that, we use it when we look at growth rates, and many economical phenomena is described by exponential growth, so you can come across Euler's number in there. There's another place where Euler's number is used, and that is the focus of this video, which is the natural log. Natural log is a special log. We refer to natural log often by ln, and if I use ln of a, what we actually mean is the e base logarithm of a. Now, very often in economics, we don't write ln a, we just simply use loga. So in economics, loga, log without any base, will mean the natural logarithm of a, so ln a. Now you have to be careful because in mathematics, log of a normally refers to base 10 logarithm. And just to confuse things a little bit, computer science also use log, but in computer science, the log without any base will most likely refer to base 2 logarithm. So be careful, there is this discrepancy amongst the sciences in this notation. However, if I ever use this log in our videos, remember we're always going to refer to natural logarithm because these videos are all for economics. Let us make some more space so we can continue the conversation. When it comes to calculating logarithmic values, there are very few values which you can actually calculate the logarithm by hand exactly. Therefore, it's important that we know how to use the calculator. And also, we have to be careful because let's say log base 5 plus 2, it's definitely not equal to log base 5 plus 2. Again, remember, brackets mean priority. So, on the left hand side, we're actually calculating log base 5, 7, and on the right hand side, we're calculating log base 5, 5 plus 2. And log base 5 gives me 1. So this is actually equal to 3. While this side is going to have to be something smaller because if I raise 5 to some power, I'm gonna have to get 7. That's basically what this log means here. And we have to remember that 5 cubed is 125, so it's definitely much bigger than 7. So the two sides are absolutely not equal. I strongly suggest that you familiarize yourself how your scientific calculator works when it comes to logarithms. Some calculators only have one log button, for which you always have to type in the different bases and the different arguments. Some calculators have got more functionality, therefore they can have some pre-programmed logs, and some of them have got the natural logarithm with ln pre-programmed, and some of them also have got the base 10 logarithm log pre-programmed. Now, one important thing about with this calculator uses is to be aware of whether you need to pay special attention to brackets. In some of the older generations of calculators, you have to pay attention to the brackets, specifically to close the brackets behind the log when you intend the log to close. So, for example, if you want to calculate log 5 plus 2, you need to make sure that you close the bracket after the 2. But if you want to calculate log 5 plus 2, you need to make sure you close the bracket behind the 5. So on the calculator, you would be seeing something like this for your calculation. Now, after this short detour, let's look at some examples. And for that, I'm going to have to make a little bit more space. So what does it mean to have ln of 10? What does it equal to? Well, remember ln is base e, so basically we're trying to find out what power do I need to raise e to so that the answer is equal to 10. Now remember, e was 2.712, 2 decimal places, and that straight away presents a challenge. I will not get this power exactly because e itself cannot be represented as an exact decimal number. Therefore, raising it to a power to get 10 can get very tricky. So we have to enlist the help of the calculator. So you want to turn your calculator on. You want to find the natural log button if you have one. If you don't have a natural log button, you have to press in log and put in the base of e. Most calculators have e programmed into them, so you will be able to use that. My calculator have got an ln button, so I'm going to press that. And then I'm going to type in 10. And I'm going to make sure I don't forget to close the bracket and press the equal sign. It's going to give me 2.3022 decimal places. It's always a good practice to round your answers to 2 decimal places. So what does this mean? Well, it means that if I was to raise e to more or less 2 to the 30 power, I should be getting 10. Let us check that. My calculator also has a function of raising numbers to the e power, so I'm going to enlist the help of that functionality, and I'm going to type in 2.30 into the power, and the answer is 9.9742 rounded to 4 decimal places. Now, there is a discrepancy here, and that discrepancy comes from 2 places. One, the calculator has got a limited memory. Therefore, it cannot represent e itself exactly. It can represent e very precisely, but not exactly. Also, I've rounded my ln 10 answer. Therefore, I have got that tiny little bit of difference of 0.03, which is my error in my calculation. So, you have to be careful, and you have to remember that whenever you're going to work with Euler's number, you will have some margin of error. Let's look at the next example. What is ln of 2? Well, again, I have to use the calculator. So I'm going to press the button ln. I'm going to put 2 behind it, close the bracket, and hit the equal sign. So ln of 2 is going to be 0.69. Again, I've done it to 2 decimal places. Next example. ln of e. Well, I know that this has to be equal to 1. Why do I know this? I know that ln is log base e, and the argument is e. So in the background, I'm asking myself the question, what power do I need to raise the base e? So that's going to be equal to e itself. And that's basically e to the first is equal to e because every number raised to the first power is itself. Remember, we discussed this in details in a video in the exponential series, which I'm going to link for you. So whenever you see ln e, that's always going to be equal to 1. And I'd like to draw your attention to this specific fact in a slightly different form. So in some textbooks, you might see this as log of e being equal to 1. Again, remember that in economics, sometimes log will mean natural logarithm. Let's look at our next example. ln of 1. What does it equal to? Again, we need to remind ourselves that ln is base e log, and we want the argument of 1 in this specific case. What power do I need to raise e so that the answer will be 1? And again, in the same video I referred to a couple of minutes ago, we also discussed that any number to the 0 power is always equal to 1. So ln of 1 is always equal to 0. Remember, the log is always the power. Making a bit more space will allow us to write out a different form of this equality. So sometimes you might see log of 1 equal to 0 in economics should your notes or textbooks use log instead of ln. And our last example for the video is ln of 1 over e squared. What is this equal to? Well, 1 over e squared is equal to e to the negative 2. Remember, in the exponent series, we talked about what negative powers are. I'm going to link the video again for you. And anything 1 over can be rewritten as a negative power. So, in this case, we need to raise e to the negative 2. Therefore, this is equal to negative 2. So, ln 1 over e squared is just simply negative 2 in hiding. I hope you found this video useful. I hope you feel that you know more about the natural logarithm now that you did before the video. Thank you for watching. In the next video, we will talk about numbers as logarithms. So basically, we will discuss about when can we replace logs simply with numbers. I hope to see you there. Thank you for watching. Bye.